Anthony D. Oh, yes, in a little bit. All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Woo, woo. How's everybody doing? Good? So warm-up number 29 is on the screen. Get started, please. I'll give you some time for that. See if you can do, 5 minutes tops. By now you should be able to do that. All right, copy and. All right, let's see where we're at. So, yesterday I walked you through those once again, just to make sure we had them, yes? So, here goes number one more time. 1A. How can I write 40 in factored form? Well, let's see, Mr. Q. 5 times 8 is 40. And then 8 can be written as 2 times 2 times 2. Yes? So this is 2 times 2 times 2 times 5. Which means 72 is, let's see, 8 times 9, yes? And 8 we said was 2 times 2 times 2. And 9 would be what? 3 times 3. All right. So, with that said, do you see any giant ones? 1, 2, 3 of them. So what do we have left? 5 over 9. And we got that. Okay? Now, I want you to practice this process like I said. I'm going slow, and I'm bringing it slowly. That's one of my strategies. So like that, when we get to that session, you're going to be like, let's go. 1B. Factored form for 1B, let's see, 21 could be written as what? 3 times 7 and x times x. So far so good, yes? The denominator, what would be GCF for these? 7x to the third. 1, 2, 3. And what's left in parentheses? X, it's what? GCF? What was GCF, guys? 7x to the third, yes? Can we divide by 7 both terms? Do both of them have x to the third? I just wrote it out here in a different way, in factored form. And what's left? X minus 4. Therefore, therefore, right there, 4, no, never mind. Giant ones, yes, the 7. What else? 2 of these x's. So what's left on the numerator? 3 over denominator, x times x minus 4. Woo-wee. And have you got that by yourself? Okay. Number 2. Factors for number 2. Share with your neighbor before Maya G gives us the factors. What'd you get for factors of x squared minus 5x plus 24? Factors are Maya G. X minus 8 and x plus 4. Wait a minute, but that means both of them should be positive. Let's see. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Is there anything that you add or subtract that gives us positive 24 and we get negative 5? No. Unfactorable. You're like, what? Yeah. All right. Go to this one. Group. GCF for these is x squared. We're left with x plus 3. GCF for this one is negative 1, and we're left with x plus 3. Therefore, my factors are x plus 3. What's left? X squared minus 1. Do you see a red flag there, though? Let's see, some of you remember. Isn't this a square? Isn't this a minus? Let's see, can we take the square root of this? Yes, x and x. Can we take the square root of this? Yes, 1 and 1. If it's a subtraction, that means one of them is positive, the other one is negative, and bring down the x plus 3, and these are my factors. Yes, so far so good? Yes? Yes, Mr. Q, we love these. Give us a pop party. All right. Looks like a plan. Let's go to number 4. Yeah, guys, and like I said, they're just going to continue coming back, those polynomials. You guys got to get a hold of them, okay? They're not going away all year, and you're going to see that today. Again, we're cranking it up a bit. All right, here we go. Number 4, solve for y. What'd you get for that one? Your equation, y equals what? Jaden. Okay, help him out, Andrew. It's right there. You got it? All right, let's see. Anthony D. Y equals. Hands, have you got that? That is correct. Once again, we leave this by itself, plus 9x plus 9x. We end up with negative 3y equals 9x plus 12, and then we divide by negative 3. That's how we get there. Okay, so with that said, evaluating each one of these, I'm going to do it in my noodle. Ready? First x value is what? Negative 1. So let's see. What is negative 1 times negative 3? Minus 4. Next. Negative 3 times 0. 0. Minus 4. Negative 4. And the last one. Negative 3 times 5. Negative 15 minus 4. All right. All right, hands, have you got something like that? All right. And last but not least, here we go. Add or subtract. Let's see, how did we do this one yesterday and the other day? I said, what would be the GCF for these two denominators? Tell your neighbor, GCF for the two denominators. Everyone? 5 and 5. So, how do we write 25 using 5? 5 times 5. How do we write 20 using 5? 5 times 4. Therefore, again, let's go. What does this have that this one needs? An extra 5, so we multiply times 5, top and bottom. That is correct. What does this one have that this one needs? Times 4 times 4. So, 5 times 5 is 25 times 4, that's 100. That's our common denominator. So, 4 times 2, 8. 3 times 5, 15. 100 common denominator. Oh, and look at that. Aw. 23 Michael Jordan. Let's go. Let's go. That was just a coincidence, by the way. Anyways, get your stuff. Get out the way, please. Oh, yeah. New seating arrangement, and it's recorded. Let's go. All right, so warm-up number 29. We already finished. We're moving on to quadratic equations. Let's go. One of my favorites. Tonight's hopefully only 6 problems, only. So make sure you stay focused. Today, in regards to rigorous, I rate it like from 1 to 5, like 4.9. In regards to being good, I mean that you're going to be good with it. So, okay. Not that it's like challenging. That would be another word. Yeah. No, it's going to be good. You'll see it. You're going to be like, oh, I want some more, Mr. Q. All right. Gotcha. So, Warm-up number 29, quadratic equations. Home plate, 6 problems only. All right? We good? All right, copy the code for tonight. VSB MD. VSB MD. VSB MD. So, last night's home plate was your study guide. That's a gift from me to you. Thank you, Mr. Q. You're welcome. That was just so that you can get practice in, because you're going to need all that for what we're going to do today. Man, I got this. My goodness. But tonight's home plate, it's only 6 itty-bitty problems. Only. Reminder, tutoring after school. Be there or be elsewhere. Get it? There or there. All right, here we go. I can solve and graph quadratic equations by what? Graphing, using square roots, and factoring. I can solve and graph quadratic equations by graphing, using square roots, and factoring. So if you notice, we're moving on to a different kind of concept. That means we do need a Ferrer model. We do need a Ferrer model. And what's the concept? Quadratic equations. I'll give you some time. Copy that. Set up your Cornell notes. So, quadratic equations. Quadratic equations, guys, are one of those, or functions, we're getting closer to functions, are one of those that they're found everywhere and in everything, pretty much, okay? One intro that I like to make, aside from using like tiles and stuff, is my basketball. Aww, here it is. And believe it or not, the way Earth and the way planets work, just like a basketball, have to do a lot with quadratic equations. You're like, what? Yeah, you can compute stuff with it. So if I was to spin this ball on my finger, you guys think it's going to stay there? Of course. Let's go. What makes it stay there? I mean, aside from my skills. Well, there's gravity. There's the turning of the ball and everything collapsing within. That's why, guys, we don't fall off Earth. Why? Because it's spinning just like the ball. Does that make sense? Yeah? You're like, Mr. Q, but can you do it with a left hand? Let's see if I can. I haven't done this in a while. Hold on. I got this. Almost got it. So, if I was to spin it with both hands, or 2 balls, 1 on each hand, which I can, and I'll show you some other time, what keeps it there is the spinning, number 1, gravity, number 2, and all those things we're going to be looking at pretty soon using quadratic equations. So, and a little tip for my basketball people, by now you should be able to shoot with both hands in high school, hopefully. Anyways, all right. So, quadratic equations, what are they? They are 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. And by now, I think this vocabulary should be self-explanatory, right? Yeah, tell your neighbor what that says, according to the definition. What does that say? Talk it over to your neighbor. What does that mean? 2 variable equations, highest degree of 2. Talk it over to your neighbor. So, think about it. 2 variable equations, highest degree 2. Got it? Let's see if your noodle tells you the truth. Examples. 2 variable equations, x and y, highest degree of 2. Okay, look at this one. 2 variables, yes, x and y, highest degree of 2. How about this one? Yes. Okay. Copy that, please. All right, so once again, quadratic equations. Two variable equations where the highest degree is 2. Okay, I think we got it. However, writing utensils down, look up really quick. Look at the examples. If you were to cover part of it, do you see polynomials in there? Do you guys see it or no? Watch. For the first one, cover the y and the equal signs. Do you guys see a polynomial there? Yes. Look at the second one. Cover the equal sign and the y as well. Same thing for the third one. All right. Non-examples. Don't copy this. Look at them. Tell your neighbor why these are not quadratic equations. Talk about your neighbor. Why are those not quadratic equations? Why are those not? All right. Good conversation. Let's see. For this one and this one, Jacob, why are these not quadratic equations? No equal sign. We need an equal sign to make it an equation. That is correct. How about this one? Why is this one not a quadratic equation? Look at this. Look at that. How about that one? Anthony E. Doesn't have a second variable. That's one thing. What else? So it's missing the y. What else is it missing? Tell your neighbor, what else is it missing? Second degree. That is correct. It has to be a second degree. So copy those non-examples. I'll give you the hashtags. Two variable equations and highest degree of 2. Two variable equations and highest degree of 2. So students, quadratic equation students. All right. So, questions, comments, autographs? We good? All right, let's continue. So, example number 1, copy that. Solve using square roots. Today's going to go super fast, but you're going to see how it's fairly straightforward. You're going to be like, oh, I got this. Oh, yeah, we got this. Example number 1 reads, solve using square roots. Solve using square roots. Okay. X squared minus 9 equals y. X squared minus 9 equals y. All right. Here we go. Writing utensils down. Look up to the screen. Here goes the process. Tell your neighbor step 1 of anything that has polynomials. Tell your neighbor the first step. Step 1. Everyone, step 1. Standard form. That is correct. Okay, so don't copy that. I'm just going to go through the process and then I'll have a copy right after. So let's see. Is this in standard form? Highest degree of 2. This is 0 on this side. That's standard form and equal to y. Yes, from now on, whenever I talk about quadratic equation, it has to be equal to what? Y. Okay, the y has to be by itself. Step 2. Make y 0. Are we there so far? Okay, so step 1, standard form, yes. Then make y 0. Step 3, solve for x. Writing utensils down, you're paying attention. Here it goes. To leave x by itself, what do? Plus 9, x squared equals 2. 9, am I done? No, we need to solve for x. How can I get rid of this squared? Square root. Whatever I do to one side, I do to the other. That's why this is called using what? Square roots. So therefore, x equals plus minus 3. Copy that, please. From 1 to 5, how comfortable are you with this? Got some 4s, 5s. Okay, we'll get there. Now check this out. Whenever we get an answer for a quadratic equation, by now I'm going to give you the names of this. This is known as the solution. Write it in there, please. It's also known as X-Intercepts, also known as roots. Why roots? Did everybody find out why roots? Because we used what? Square roots. And the last one, they're also known as zeros. And we'll get there when we get there, and I'll show you that. These are all the four names of this. Okay? All right. So, process, standard form, set y equal to 0, and solve for x. And at the end, do square roots. All right, let's do one together. Here we go. Copy this one. Example 1Q, x squared minus 64 equals y. X squared minus 64 equals y. All right, here we go. Step 1, standard form. Yes, and equal to y. Step 2. Everyone? Equal to 0, okay. X squared minus 64. Step 3, solve. What do? Martin, add 64, add 64. X squared equals 64. And at the end, everyone, square root, x equals plus minus. Oh, I'm waiting for you guys. 8, that is correct. Now, for those of you that are saying, what is this plus minus, Mr. Q? Well, let me ask you. Square roots are what? What number times itself, yes? So what number times itself gives us 64? 8 times 8, is that correct? How about negative 8 times negative 8? Yeah, so therefore, plus 8 and negative 8. And what are these called? Solutions. What else? X-intercepts. What else? Roots. What else? Zeros. All right, do this next one by yourself. Example 1 mega cube. 3x squared minus 27 equals y. Copy and go. All right, let's see. Brandon, Felix, what is the first step? What'd you do? Standard form, let's see. Is it in standard form? Yes. And what is the second step? Let's go. Change the y to 0. So we got 3x squared minus 27. Hands if you got it right there. Okay. Next step. Pass someone. Add 27 to both sides. Add 27. Oh, let it go. Let it go. Have you guys heard that song? No? You're like, oh, yeah. Bring 3x squared equals 27 down. Pass someone. Anthony D. All right. What do we do from there? Divide by 3. Divide by 3. X squared equals 9. So far, so good. And everyone, what's the last step? Square root and square root, because that's why we're using what? Square roots. So this cancels this. We're left with x equals plus minus 3. And these are my solutions. X-intercepts, roots, zeros. And have you got that? All right. I think we got it, yes? Yes, Mr. Q. All right. Let's see. One more, last one. Copy that one, please. See if you can go a little bit faster now. 4x squared minus 100 equals y. Copy that and go. And this one we're going to give to Kimberly once she's done. All right, go. All right, here we go. So, Kimberly, I'm going to get you started. Step 1, standard form, yes. And then change to y. Okay. Change the y into 0. Okay, continue from there. Add 100, add 100. We got 4x squared equals 100. Then what do? Divide by 4, so that is x squared equals 25. And then square root, x equals plus minus 5. And what are these called without looking at your notes? Tell your neighbor, what are those called without looking at your notes? Solutions, X-intercepts, roots, and zeros. 4 names. You need to know the names. Yes? All right. From 1 to 5, I'll provide you with this. We got it. Yes? Is it coming back? Some of you did this before. Hopefully, I mainstreamed it a little bit. Look at this one. Don't copy it. Look at it. Step 1. Step 2. Step 3. Step 4. And then square root, so we end up with, let's see, x equals plus minus square root of 8. And have you got that? Yes? Okay. Yeah, unless I can show you how to get the decimal for this, but for right now, for the sake of the process. All right, look at this one. What do you guys notice? They already did the y equal to what? And then we just continue from there. Does that make sense? Okay? So, we got this. Which takes us to the next method. Copy this one, example number 2, solve by factoring. Solve by factoring. Example 2, solve by factoring, x squared minus 9 equals y, x squared minus 9 equals y, x squared minus 9 equals y. All right? It's going to go fast, so pay attention. Here we go. Just copy it. I'm going to go through the process. So when you see the word factoring, factor, you should be able to think of 2 main steps that we did with polynomials. Tell your neighbor the 2 steps. Step 1 is what? And what is the second step? That is correct. Those are the first 2 steps you're going to check for. Standard form, is there a GCF? No. And step 3, again, y equals 0. X squared minus 9 equal to 0. Okay, so you'll copy a little bit, write your utensils down, look up to the screen. Here we go. Step 4, pay attention to this part. I need to factor. Ready? You're just paying attention. Basically what I'm doing, I'm covering this up and looking at this. Can I factor this? Oh yeah, that looks familiar, Mr. Q. Why? Because of the square and the minus. Therefore, there should be a difference of squares, yes? What is square root of this? What is square root of this? If this is a minus, that means this is a plus, and this is a minus. And now, all I have to do is bring down the 0. Hold on. That 0. Copy that up to right there. So let's see. Step 1, standard form. Step 2, GCF. Set y equal to 0. There it is. And then we're going to factor. Okay. Now check this out. Let me throw some numbers at you. Write your utensils down. Look up to the screen. Has nothing to do with this. I'm just making you think. Ready? What is a times 0? 0. What is 0 times b? 0. Is that correct? So so if I have a and b, or a times b, and it's still equal to 0, what do you think? What is that? A could equal to 0, or b could equal to 0. Does that make sense? Because it could be either one. We don't know which one. Is everybody following up to right there? Okay, so that takes us to this next step. Step 5. ZPP, known as zero product property. What does that mean, Mr. Q? That when you have something times something equal to 0, that means this one could be 0, or this one could be 0. And at the end, number 6, solve. Copy that, and let's finish it off. Minus 3 minus 3, x equals negative 3, plus 3 plus 3, x equals 3. And what are the name of these? Solutions, X-intercepts, roots, zeros. How we doing? So once again, process, standard form, GCF, y equal to 0, factor, and the rest is history. Let's do another one. Here we go. I'm going to go a little faster just to, we did one of this. Copy this one. Example 2 super cube. 2x squared minus 50 equals y. 2x squared minus 50 equals y. 2x squared minus 50 equals y. Step 1, is it in standard form? Yes, from highest to lowest degree. Step 2, is there a GCF? Yeah, what is that? 2, and we're left with x squared minus 25, and all that equals to y, but I'm going to change the y to what? 0. Next step, factor. Can I factor inside of the parentheses? Let's see, square root of this. Yes. Square root of this. 5 and 5. If it's a minus, that means this is a plus, this is a minus. And then you bring down our BFF, which is 2. And what is our last step? ZPP, or zero product property. That means that 2 could equal to 0, x plus 5 could equal to 0, and x minus 5 equal to 0. All right? So, question, is 2 equal to 0? No, we just got rid of our BFF. Sorry. This one, minus 5 minus 5, x equals negative 5, plus 5 plus 5, x equals 5. From 1 to 5, how come to right, you have to right there? Okay? All right. Look up. Oh, look at this one. Is it equal to 0? No. What can we do to make it equal to 0? Subtract 20 from each side. 5x squared minus 20 equals to 0. Do you know what to do from there? Yes. Okay? Look at this one. Don't copy it. Is it in standard form? Yes. Is there a GCF? No. Set it equal to 0. Can I factor this next? Yes, so that's 6, 5, 2, and 3, and then the rest is history. And you're going to have 2 factors equal to 0. And what do we do with 2 factors equal to 0? The same thing that we did here. Okay? All right. And that takes us to graphing. Copy this one. Example number 3. Last one. And this is your favorite. Here we go. For graphing. Step 1, it needs to be equal to y. Step 2, make a table. X, y. Are we there? So for x, we're going to substitute 0. All right? And then for y, we're going to substitute 0. And watch, I'm going to substitute it, I'll just leave it at once. so you guys can see it. I'll show you right now. All right, here we go. So for x, if we substitute 0 here, what is 0 squared? Let me do that. 0 squared minus 9 equals to y. What is this, guys? And that leaves us with negative 9. Hold on, we're almost done. Next, I'm going to substitute 0 for y. Look up. X squared minus 9 equal to 0. Can we solve for x? What method do you want to use? Square roots, factoring, square roots, okay? Plus 9, we're almost done. Square roots, x equals plus minus 3. I mean positive 3 and negative 3. So now I add the 0. Hold on. But they want by graphing, so you can start backing up. Here goes the graph portion. 0, negative 9, 0, negative 9. It's right there. Then we got 3, 0, and negative 3, 0. Check this out. Students, parabolas, students. What are my solutions? My solution is here and here. All right, let's see how you do with the home plate. Have a good one, guys. Enjoy your home plate. Tutoring after school. See you guys tomorrow. Bye.